Addendum to Chapter 8, Section 4 notes on polynomial inequalities. Okay, we're going to talk about what happens when you have a bounce. When you have a bounce in your graph, okay? So first problem I want us to go over, let's talk about this. Let's talk about x minus 2 quantity squared times x plus 3. Let's make it greater than or equal to 0. Okay. So I'm in standard form, right? Check the box. Standard form means what? It's equal to 0, right? Positive lead coefficient. I'm factored, right? I'm all factored. So what are my two zeros?
2.
All right, and what are the multiplicities for those?
3.
X equals 2. What's the multiplicity for x equals 2?
2.
Yeah, 2. So it's even. What about 4x equals negative 3? All right. Good. 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 What's the degree of my polynomial? 3. Where'd 3 come from? Just a little check. Right. We added the multiplicities. Right. Lead coefficient's positive. Right. 1 times 1 times 1 is positive. Odd positive. We're going to fall left, rise right. Where did Mr. Rushka get that from? The charts. All right, which you can memorize by doing the end behavior dance. Hit the end behavior, okay? All right, so let's go ahead and graph this. So I'm going to plot 2 and negative 3 with what? Solid dots or open circles? Solid dots. Solid dots. Good stuff. Good stuff. I should probably stand near the computer, so here's my board. All right, and then fall left. So I'm going to draw a down arrow out of the left dot. Rise right. I'm going to draw an up arrow out of the right dot. Jack Schneider, get off Clash of Clans or whatever. Whatever you're playing. Is that Clash of Clans? Yeah. All right. So then, how do I finish the graph? What do I do? It bounces off this one? Okay. Okay, it'll bounce off that. And then what does it do with this one?
Cross.
All right, you guys got that wrong. Sorry.
No, like it go make it go up.
So this is negative 3, this is 2. What does it do at negative 3? It crosses, right? Odd multiplicity, so it crosses through negative 3, so boom, right, goes straight to the other side of the horizontal axis. And then I'm going to have a little hump, and then what happens here? Bounces. Okay, there we go. Where do I shade? Where do I shade? Where do I shade? Above the horizontal axis, right? Because it's a greater than or equal to. All right? So what's my answer then?
Negative.
What's the leftmost point in the shaded region? What's the rightmost point? Positive infinity. Okay? 2 is marked there, but we don't actually have to do anything with it in our interval answer. Right? Because it's just another point. It's just another point in our shaded area. Even though it's labeled here, it's still just another point in the shaded area, right? It'd be like me labeling this point or something. It wouldn't change my answer. It's just, yeah. Does that make sense? Okay. All right, why is negative 3 have a brackets? Because of the solid dot, right? It's or equal to it. And then why does infinity have a parenthesis? Yes, okay. If someone puts a bracket on an infinity, we should have consequences. What should we do? We'll do wind sprints on the football field. Am I allowed to do that? You have to do it if you're the coach and the PE teacher, so I don't know. I feel like I just. Okay, we'll do the mathematical equivalent of wind sprints. I'll give you like a 40 problem worksheet on completing the square. Right there. That's terrible. I'm going to give you the mathematical equivalent of wind sprints. Okay, 40 problem pop quiz on completing the square. Mr. Mann, keep the phone away, please. testing me, just taking my patience, just whittling a little more off. All right, good. So I'm going to change this up, guys. Okay, I'm going to throw you a change up. Okay? Instead of greater than or equal to 0, I'm going to make this a greater than 0. So what changes?
Open circle.
So instead of solid dots, I'm going to have open circles.
And then your like the end, like your your brackets are
Ooh, there's a little more to it. So I'm still going to shade where?
above.
Above. Good. Okay, I'm still going to shade above. What's my interval going to be now? -3 to what? 2. Ooh, good job. You guys got that, right? Is 2 part of my shaded region now? No, I have to omit 2. How do I indicate that 2 is not part of my shaded region anymore? 2 parenthesis U parenthesis 2. Okay, like that.
Why is 2 omitted?
2 is omitted because I'm shading everywhere where the graph, since it's just a greater than. Before it was a greater than or equal to, so I shaded everywhere where the graph was above the horizontal axis or touching it. Now, because I just have a greater than symbol, I need to shade only where the graph is above, where it touches, not part of my interval anymore, not part of my answer. So it touches at 2, right? So 2, got to throw 2 out. Yeah. So the way I do that, I go -3 to 2, right, with parentheses, because these are both open circles, right? It stops at 2, and then it starts back up again to the right of 2. Does that make sense? Yeah. If you want to, if you find this easier, I would accept this as well. If you guys would rather just like, hey, just take 2 out, you can just do minus and then a 2 in squigglies. Either one, I'll take either of these. They're both the answer.
Can we do another one like that?
Yeah, sure. I would love to. I wish I did. Let's see this. I got a good one. All right. Let's do. Oh. Oh, man. Throwing you guys a curveball. High spin rate.
Should just take the square root of it first.
Yeah, so let's factor these, okay? You don't square root anything. Well, okay, you're actually really smart. You could, actually. That's really clever. We're not going to do that here, though, okay? Let's factor this. Let's factor this to x plus 1 squared times x minus 1 squared. We keep the square there. Okay, does that make sense? The x squared plus 1 becomes x plus 1 and x minus 1. And then we take the square and we distribute it. Because it's a times, not a plus or minus. And then this is x minus 3 squared times x plus 3 squared. Whoa.
Wait,
Hello.
why'd you put 2 for each one even though you split it up? Like 2
So I split it up, right?
Yeah.
So I would not have included the squares if those squares at the beginning did not exist. Okay? So are you following like that? Like if I had just done that, would you follow that?
Yeah.
Okay.
Wouldn't it just be 1 at that point because you can split them up?
Yeah. Okay, so I factored these, right? But since like the original one was squared, I have to distribute the square when I factor. It's the same reason like if I have AB squared, this becomes A squared times B squared. You have to like distribute. Don't worry too much about that. If you're not going to see it with something like that.
But doesn't it change them? Like, it would like. Okay, never mind. I get it.
Okay. One of my zeros. Okay. They all have what multiplicity? Multiplicity is 2, which is what? Even. That's called parity. Whether it's even or odd, it's called parity, if you want to sound fancy. So what's my graph going to do at all of those? It's going to bounce. It's going to bounce at all of them. What's the degree of my polynomial? Degree equals 8, which is even. Okay. Lead coefficient is what? What's 1 times 1 times 1 times 1 times 1? Yeah. It equals 1. So even positive, it's going to rise right, rise left. If you don't believe me, look at the charts. If you don't believe the chart, go on like Wolfram Math World and look at a proof of the charts. Let's go ahead and graph this. This is a fun one. Okay, so I'm going to plot my zeros with what kind of circle? Closed, right? Solid dots, solid dots. So -3, -1, +1, +3. -3, -1, +1, +3. I'm going to rise right and left, right? Okay. And I bounce off all of those, right? Bounce, bounce, bounce. Okay. So I shade where?
Below.
So I shade everything that's below the horizontal axis or touching it, right? Or touching it. So just the points, right? I just want the dots. How do I write the dots down? Anyone know? This is not an interval. Since they're just single points, just list them off. Just list them off for me. What? You could do squiggly, yeah. If you just list them off, that's fine. Mathematicians would write like that. The set of all solutions. Okay. There we go. Curveball, right? That's a curveball. It's a curveball.
Wouldn't it just be easier though to just take the square root of it first?
Clever, clever. Can you do that?
Then you get
Square
rid of,
roots.
then you get rid of all of the exponents.
But then like the graph changes.
Yeah. So I'm
Then the graph like changes. Because then they become all crosses, right? Yeah, that's a good question. This is actually a really good mathematical question. This is like a little bit advanced. There's like some like nuance going on. Because yeah, so Macy's point is like, why not just take the square root and then it'll cancel the squares, and then we just have a 0 on the left, on the right side. That's Macy's point, and I think it's really clever. But if you do that, like it doesn't change the inequality, but it changes the graph, right? These would all become, the 2's would all go away. They'd all become crosses, and that would change the graph. What I'm thinking, Macy, I'm thinking you can't, because when you cross this out, I think you have to do, no, because that wouldn't make sense either. Yeah. I don't know why. That's like, there's some like weird mathematical nuance going on there. It's something to do, I think, with the fact that you have to do plus or minus technically with your square root. Because that would change the graph. That's a really good question. I'm going to look this up. That's beyond the scope of this course, though, so don't worry about what I just said unless you're interested in what I just said. Okay. All right. All right, I'm going to make a bigger curveball, bigger curveball. Okay. Instead of less than or equal to, I'm just going to make it a less than. What's going to happen? They all become open circles, right?
you not shade it. You only shade
Can't
it.
shade anything. Boo-hoo. So what's my answer?
No solution.
No. Please do empty set. No solution. Write that simple. Empty set. There are no solutions in my set. The set of solutions is empty. It's the empty set. The empty set is the set which contains no elements. It is contained in every set. Every set contains the empty. Sorry, don't worry about what I just said. No. You can work that if you're interested. The empty set, there's a proof the empty set is contained in every set. You know it? That means the empty set contains itself. Every set contains itself. It feels like a paradox. All right, any questions? Any more questions on that sort of thing? Right, so these are just like the trick ones. These are like the, if you guys can do this stuff on the homework, you're good. actually know some of these, though. I'm sure there'll be at least one bounce on there. So we're doing well, though. We have good intuition. Let's pass those up, please.